Okay, Assalamualaikum and hi everyone. Right, so today we are going to make a quick review on pre-PSPM chemistry SK015 2019-2020. Alright, so for the first question, in the question is already given the mass of solute, which refer to the copper sulfate, and this is refer to the mass of solute 169 gram, and also the volume 820 ml of solution, and also given the density of the solution. So you have to calculate the percentage by mass of copper sulfate and also the molarity of the solution. Right? So what we should do, right? So first of all, you have to calculate the mass of solution because in question is already given the density, right? Okay, so you will get 1 mark for the formula. Okay, another 1 mark with the final answer with correct unit. Okay, second mark. So substitute the mass of solute, that is 979.9 gram, into the formula of percentage by mass. So you get the final answer would be 17.04%. Third mark is given to the formula or the substitution. Mark number 4 is refer to the final answer with correct unit. So unit here is refer to the percentage. Alright, so for 1A2, molarity of the solution. So first step, you have to calculate the number of mole of solute. Alright, so please remember for the number of mole of solute here, so you have to take the answer 3 to 4 decimal places with the unit. Calculate the molarity, so substitute the mole of solute that is referred to copper sulfate into the formula of molarity. Then you get the final answer here is 1.28 molar. Mark number 5 is refer to the final answer with correct unit. That's refer to the mole. Okay, and then number 6 is refer to the formula of molarity or the substitution. Okay, and then the final mark would be the final answer with the correct unit, that is molar. For the final answer, you can write your answer in 2 decimal places. Alright, so next, so for B, given the mass for both reactant, okay, so, and then you have to calculate the limiting reactant and the maximum amount in gram of product form, okay, and then the mass of excess reactant that is left after the completion. Right, so this is the hint. Okay, this is the hint. When the question give to you both data of the reactant, so meaning that the question must be related to the limiting reactant. Okay, right. So first of all, you have to calculate the mole available for both reactant. So remember, so for the number of mole, so you should present in 3 to 4 decimal place with the correct unit that is referred to mole. The mark is given to the calculation of mole, okay, with the correct unit. Okay, next, we want to calculate the mole needed using mole relation. So refer back to the equation. So there are 1 mole of CO, okay, react with 2 mole of hydrogen gas. So that's why the mole relation here is 1 mole of CO equivalent to 2 mole of hydrogen gas. Substitute the mole available. Either you can choose mole available for CO or mole available for H2 gas. So for this example, is referring to the mole available of CO. So therefore, we'll get the mole needed for hydrogen gas. Okay, next, refer to the mark given. So first mark, for the mole relation, 1 mark. So this is not the final calculation. So that's why you have to show your answer in 3 to 4 decimal places with the correct unit. Okay, step number 3, compare mole needed hydrogen gas with the mole available. Okay, so when refer to here, so we notice that mole H2 needed, okay, needed here is lower than mole available. So therefore, H2 is the excess reactant. And the other reactant that is referred to CO, it should be the limiting reactant. Okay. Right. So another 2 marks here is given to the compare more. Okay. And then the final answer. So next, number B2. What is the maximum amount or in gram of product form? Okay. Which refer to the methanol. Right. So the first step, you have to calculate the mole product form using mole relation. Right, so from here, so since we already determined the limiting reactant which refer to CO, so the mole of product form, we have to compare it with CO. Even though the mole here is the same, okay, 1 to 1, but you still have to show the calculation. Okay, alright, next, calculate the mass of product form. So mole, okay, number of mole of product form times with its molar mass. Then you get the final answer is 8.52 gram. Okay, so first mark is given to you when you calculate the mole of product form. Okay, second is refer to the final answer with the correct unit. Okay, right. So next, step number 3, calculate the mole of excess reactant reacted. Right, so excess here is referred to the hydrogen gas, so that's why you have to calculate the mole of H2 reacted. Right, so by using the mole relation. Okay, so 1 mole of CO is equivalent to 2 mole of H2. Okay, and then substitute the mole of available of CO, and we will get the mole of H2 reacted. Okay, next, how to calculate mole of H2 left over, meaning that the balance. So, mole available of H2 minus mole reacted of H2, then you get the mole of H2 left over. And then, how to calculate the mass of H2. So, times with its molar mass. Okay, remember H2 is 2 hydrogen, so 2 gram per mole. For this part, you will get 3 marks. So first marks when you calculate the mole H2 reacted, and then mole of H2 left over, and mass of H2. Okay, with the unit here is gram. So for the whole mark for the first question is 17 marks. Okay, so now we move to the second question that is referred to the chapter 2. So please remember, one question is referred to one chapter. So number 1 is referred to the chapter 1. So number 2 is referred for chapter 2. So given to you the Balmer series, and also given to you the wavelength. Unit is nanometer. So you have to calculate the frequency of this line. So you can use the formula of frequency is equals to C over lambda. Okay. But remember, first of all, you have to convert the unit of wavelength, that is the nanometer, into meter. So you can refer to my previous video how to convert from nanometer to meter. Alright, so next you will get the final answer. Okay, that is 6.17 times 10 power of 14 per second. So remember, unit is insisted. Unit is compulsory. Alright, next, determine the electronic transition associated with this line. Alright, so we know that this is the Balmer series, and the ground state for Balmer series is n equals to 2. So n equals to 2 is referred to the n1. Why? Because n1 should be smaller than n2. So n2 here is referred to the excited state. So for this question, first of all, we have to calculate the n for the excited state, n2, which refer to the excited state. So therefore, since the question given to you the wavelength, so it is safe if you use this formula, Rybert equation. Okay, and remember the value of RH here, so you should use 1.097 times 10 power of 7. And substitute all the values. Okay, wavelength should be in meter. Okay, because the value of RH here is per meter. Okay, and then finally you will get N2 is equals to 4. And then you have to make a conclusion. Okay, determine the electron transition. So electron may transition from energy level N equals to 4 to N equals to 2 because it's referring to the line. So line is formed when electron drop from higher energy level, which refers to the excited state, that is N equals to 4, to the ground state, that is N equals to 2. Alright, next, state the region of the electromagnetic spectrum. Okay, for Balmer-Sea rate, of course, this is visible region. Okay, so how many marks that we will get here? Right, so for the second part, so it's given to the formula. Okay, make sure you write the formula. And then the substitution. Okay, and then the final answer. And lastly is the conclusion. Right. Okay, for number 3. So because the question here just state, so you just write the final answer. That is referred to the visible region. Okay, we move to question number 2B. Alright, it's given to you the proton number of calcium is 20. Write the electronic configuration of calcium. And then you have to write the set of quantum numbers of the valence electron. Okay, and then shape of orbital for the valence electron. And orbital diagram of the most stable calcium ion. Calcium ion. So make sure you read until the end of the sentence. Calcium ion. Okay. Alright, so the first, you can choose for B1, write the electronic configuration. You can choose either orbital diagram or SPDM notation. It's up to you. Okay. Make sure it's follow all the 3 rules that is referred to the Akbar principle, and then Pauli exclusion principle, and Hans rule. Okay. Right. So this is the sample answer. Okay. So 1 mark. Make sure you write the title here, calcium. And then the electron should be superscript. Okay, superscript. Right, next, number B2, set quantum number of the valence electron in calcium. Alright, so it's mentioned here valence electron. So valence here is located in 4s, and there are 2 valence electron here. That's why you have to write 2. And then the question here is also given to you. The clue here is sets the S. Got S here, so which means more than 1 set of quantum numbers. You must label the quantum numbers. For example, like this. Okay. So 4 is stand for N. L is referred to 0. Okay. Because because this is S, so that's why L equals to 0. M is referred to L when L equals to 0. M also 0. And then for the S, spin up is positive half. So the other set is 4, 0, 0, negative half, spin down. Okay, so the mark here is given to you 1 mark for each of the set quantum number. 1 plus 1. Okay, for B3, draw the shape of orbital occupied by the valence electron. Okay, so because it's, the valence electron is located in 4s, so that's why you have to draw 4s orbital. Make sure it must complete with the axis. Okay. Okay, and then also the label the subshell. Okay, so correct orbital shape with correct labeling and axis. Okay, 1 mark. Okay, next, write the orbital diagram of the most stable. Okay, the most stable of calcium ion. We know that calcium atom is located in group 2. So metal in group 2 donate 2 valence electrons, okay, in order to achieve a stable octet configuration. Okay, that's why remove 2 from 4s, the valence electron, and then we get like this. Okay, so this one is already mentioned orbital diagram. So which means you cannot write in form of SPM notation. So I already mentioned orbital diagram, so you should draw the orbital diagram. Okay. So and also with correct labeling here. So the electron spin, you have to draw spin up and spin down with the title Ca2+. Okay, 1 mark. Okay. So for second question, you will get 12 marks. Okay. Right, so we move to the third question. Explain why BH3 can form the active covalent bond with H plus but not BH3. Okay, the marks given here is 2 marks. It should have two possible reasons. Okay. Right, so first of all, the first reason is because of phosphorus, because have lone pair. Okay, so that's why it can donate. Okay, donate the lone pair to the empty of H plus ion. So H plus ion without any electron, 0 electron. So to form the active bond. Okay, and then why BH3 cannot form the active bond? Okay, because boron does not have any lone pairs. Okay, so this is 1 mark, 1 mark. Okay, correct reason. Okay, so next, so B, write an equation to show the formation of BF minus from F minus ion and BF3 molecule by using Lewis symbol and name the type of bond form. Alright, so the first mark, when it's mentioned here formation, so meaning that it should have right turn and also the product. Okay, so the first mark here, when you write correct for both right turns. Both right turn correct. Okay, with the charge here negative charge. And then BF3 with all the lone pair, so you get 1 mark. And then second mark is given to the products. Okay, this is the product, should have negative charge here. And then the fifth mark is given to you for the arrow. Arrow from donor, that is referred to fluoride ion, to the acceptor, that is the boron, 1 mark. Okay, right, next, name the type of bond form. So there are 2 options, whether you can answer dative covalent bond, 1 mark, or coordinate bond, also can be accepted, 1 mark. Okay, alright, next for 3C, phosgene COCl2 is a colorless, okay, highly toxic gas employed against drop in World War I. Okay, and used today as key reactant in organic synthesis. Draw all possible Lewis structure of phosgene. All possible. Identify the most plausible structure and explain. Okay, and then number C2, determine the molecular shape and polarity of phosgene. So, given to you, the marks, total mark here is 9 marks. Okay, so how to answer for C1? So this is the answer. Okay, so meaning that when you draw the Lewis structure, we notice that the carbon is not a chief octet yet. So therefore, you have to draw a double bond. Okay, so double bond should be between carbon and Cl. Okay, or between carbon and CO. Okay, next you calculate the formal charge. Alright, so the first and second mark is given to you for the Lewis structure, and you have to label A and B. Okay, and then which one is the most possible? Of course, the Lewis structure B, because it has the lowest formal charge. So B is 1 mark. Okay, and then lowest formal charge is 1 mark. Reason 1 mark. Okay. Alright, so next for C2, right. Okay, determine the molecular shape and the polarity of phosgene. So for this one, we have to take the most possible Lewis structure to present. So the first mark here is given to you for the Lewis structure. Okay, with the correct shape, 1 mark. Okay, and then you write the name of the shape that is referred to the trigonal planar, 1 mark. Okay, and then reason, okay, why it is polar. So because it at all the dipole moment, when you refer here, all dipole moment here. Okay, and also the reason, okay, 1 mark. Okay, show the dipole moment and also the reason. So all the dipole moment cannot cancel each other, or you can write the arrangement asymmetrical, not symmetry, or you can write mu is not equal to 0. Okay, right, so you get 1 mark. Okay, and then so give reason why the dipole moment cannot cancel each other. So oxygen is more electronegative than chlorine. Okay, so that's why cannot cancel. So the conclusion here, so phosgene is a polar molecule. Okay, mark number 5. Right, so how many total mark that we get from question number 3? You will get 15 marks. Okay, next, number 4A is about the displacement method. Okay, hydrogen gas produced is collected over water. So water displacement method, given to you the volume of gas and atmospheric pressure is 0.98, and then you have to calculate the amount of zinc metal consumed. What is the mass of zinc consumed? And then given to you the clue, another clue here is vapor pressure of water 23.8 mm Hg. Right, what should you do? First of all, you have to find out the partial pressure of hydrogen gas produced here. Okay, and it's given to you the atmospheric pressure 0.98 is referred to the total pressure. So use the formula of P total equals to partial pressure hydrogen gas plus partial pressure of water. The water vapor here is already given 23.8, convert it into ATM. So because same unit with total pressure. Okay. Alright, and then the first mark when you write the formula or the substitution, 1 mark. Okay, and then partial pressure of hydrogen gas with correct unit, 1 mark. And then you can use PV equals to nRT to calculate the mole of hydrogen gas. Okay, formula 1 mark. Substitution, another 1 more mark. Okay, so please remember to convert the unit of temperature from degree of Celsius to Kelvin. Okay, and then number 5, mark number 5 is mole of hydrogen gas. Okay, remember this is not the final calculation. Then you have to leave the answer in 4 decimal places. Okay. Okay, next, when we have already calculate mole of hydrogen gas, so we can calculate the mole of zinc chloride because here is already mentioned hydrochloric acid is the excess reactant. So which means zinc is the limiting reactant. So how to calculate mole of zinc? Okay, by using mole relation, you can calculate the mole of zinc used. Okay, 1 mole of zinc is equivalent to 1 mole of H2. Then we get the mole of zinc. So that is the mark number 6, mole relation, 1 mark. And also the mole of zinc. And finally, the mass of zinc, okay, used, consumed. So time is molar mass, you get 19.53 gram. Final answer with the correct unit. Okay, so for B, it's given to you the boiling point for several liquid. So first you have to arrange the liquid order accusing vapor pressure, and then you have to explain. So this is the sample answer. So this one is relationship between the boiling point with the vapor pressure. So the relationship is inversely proportional. Since ethanol has the highest boiling point, so it has the lowest vapor pressure. Okay, so that's why ethanol is the lowest vapor pressure. And ethanol has the lowest boiling point, it should have the highest vapor pressure. So this is the sequence. Okay, so first mark is referred to the arrangement. So you can answer, either can use symbol or you can use arrow. And below the arrow you have to label increasing vapor pressure. And then explain. Because the mark given here is 3, you should give 2 reasons why. Okay, the first reason is ethanol. Okay, has dipole-dipole forces. Methanol and ethanol have hydrogen bond. 1 mark. This is explanation 1 mark. The first point. Second point. Okay, from ethanol to ethanol, strength of intermolecular forces decreases. You can write stronger intermolecular forces, higher boiling point, lower vapor pressure. Or you can write hydrogen bond is stronger than dipole-dipole forces. And ethanol has larger size than methanol. So 1 mark. Okay. Alright, so for C, state the differences between amorphous and crystalline solid. So for the differences question, remember, so you can answer by using table form, right? So given to you 2 marks, so 1 mark each of the difference. So make sure the characteristic is the same. So example, amorphous have no well-defined, no ordered structure or random arrangement of particle. So crystalline solid contain regular repeated arrangement of particle or ordered structure. 1 mark each of the differences. And the total mark here for question 4 is 12 marks. Okay, we move to question number 5A. Right, so calculate the equilibrium constant Kp for the reaction, and in the question only given the value of Kc. Marks given here is 3 marks. So the first step, right, so since only one data is given, that is equal to Kc, so you have to use the formula of Kp equals to Kcrt power of delta N. So the first mark is given to you when you write the formula. Second mark, substitution. And please remember, convert from 160 degree of Celsius, convert it into Kelvin. And then how to calculate the delta N? Delta N, remember, total mole of the product minus total mole of the reactant. So 2 minus 1 is equals to 1. And then you get the final answer for Kp is 4.48. And remember, final answer don't have any unit. Kp or Kc. Alright, next we move to B. Okay, 5B. So given to you the equilibrium constant Kc, right? And then we have the concentration for each of the reactants and also the product. Okay, question asked is the system at equilibrium, and then you have to explain. Alright, so all the value of concentration here is referred to the initial concentration. So therefore you have to calculate the value of Qc. Alright, so the first mark is given when you write the QC expression, okay, or the substitution. Right, next, the value of QC. Okay, QC here is not the final answer, so therefore you can write in 3 to 4 decimal places. And then you compare, number 3 you compare. Okay, the third mark, comparison. So QC is bigger than KC. The reason, so system is not at equilibrium. So meaning that when QC is bigger than, which means the reactant is smaller and the product is bigger. So that's why the system shift to the left. Each reason 1 mark. Okay, alright. Okay, next, part C, 5C. Okay, state the effect on the amount of CO and the value of Kc of the point changes. So this is simple answer. So tips why we get this answer. So when the pressure is increased, okay, so pressure here is referred to the total pressure. Okay, the system will try to reduce the disturbance by decreasing the pressure. Therefore, the system will shift to the side with the smaller number of mole, which is to the left side. Solid is not accounted in the Kc or Kp expression. So therefore, the total mole for the reactant is 1. Total mole of the product is 2. So that's why the equilibrium will shift to the less number of mole. That is to the left side. Right. So because of the left side, so amount of CO will decrease. Because it's already mentioned amount of CO. Amount of CO will decrease. And the Kc value does not change. It remains constant. So this is the first mark and this is the second mark. Okay. Right, next. Right, so steam is added. Steam here is referred to the H2O in gas. When more steam is added, okay, which refer to the H2O in gas. So the system is trying to reduce the disturbance, okay, by decreasing the amount of steam. Okay. So therefore the system will shift to the right. Shift to the right, so amount of CO will increase. However, value of Kc does not change. Okay. Remember, okay, Kc does not change. Okay, for pressure and concentration, do not affect the value of Kc. Value of Kc remain constant. So mark number 3 is the refer to the amount of CO increase, and Kc remain constant. Mark number 4. Okay, we move to question number 6. Right, the final question. So give the conjugate acid. So we recap back what conjugate acid is. Species formed when a base accepts a proton. So Cn minus ion accept a proton, it will form HCN. Right, and then HCO3 minus ion accept a proton, it will form H2CO3. For both answer, 1 mark, 1 mark. Okay, calculate the concentration of H plus and OH minus of human blood, pH 7.4. First of all, pH here, we know that the formula here is pH equals to negative log concentration, H plus. So just substitute the value of pH, then we get the concentration of H plus ion. Remember, the unit should be in molar. So this is the mark number 3. And we know that by using Kw is equals to concentration H plus times concentration of OH minus. Okay, so this is the value of Kw. Substitute the values of concentration of H plus ion, and then we get the final answer. Concentration of OH minus ion is referred to 2.51 times 10 power negative 7 molar. Don't forget to write the final answer with the correct unit molar. Alright, so next, okay, C. Calcium sulfate is a partially soluble compound with KSP. 2 times 10 power negative 4. Calculate the molar solubility of CaSO4 in pure water. Right, so because this mentioned here partially soluble, so therefore always use ice table to find out the molar solubility. Make sure first you start with the assumption, let X refer to the molar solubility in pure water, and then write the equation. Since calcium sulfate is a partially soluble, so you have to use reversible arrow here, and the phase for the salt here should be in solid, and it will produce cation Ca2 plus aqueous and SO4 2 minus aqueous. Right, so for the initial concentration, right, so since salt here is in solid, so just write dash dash dash. And for the calcium is 0, and Ca2 plus 0, SO4 2 minus also 0 because not formed yet. Okay, change in concentration, you have to refer to the mole. So both ion is equals to 1. So it will increase positive X and positive X. At equilibrium, X and X. First mark the whole ice table here. Complete set with the equation. Right. Second mark, you write the KSP expression. Okay, so solid calcium sulfide is not included in the KSP expression. Right, and then substitute and the final answer. So final answer with the correct unit that is referred to the molar. Okay, the third mark. Alright, next C2. Okay, you calculate molar solubility in calcium chloride. Question also you have to perform ice table. Start with assumption, let Y is the molar solubility. Okay, in 0.2 molar CaCl2 to differentiate between molar solubility in pure water and in the CaCl2 solution. Okay. Alright, so for the initial concentration, alright, so Ca2 plus, we have the concentration, initial concentration, which refer to the concentration of calcium chloride. Okay, because 1 mole, when we dissociate CaCl2, we will get Ca2 plus and 2 mole of Cl minus ion. So therefore, the molarity of Ca2 plus is equal to the molarity of calcium chloride. 0.2. Okay, SO4 2 minus is 0, not formed yet. Okay, and next, change in concentration. Okay, it's referring to the coefficient, both are 1. So, increase, positive Y. Okay, at equilibrium, 0.2 plus Y for CH plus, and Y for SO4 2 minus. The whole set of ice table with the equation is 1 mark. Okay. Alright, second mark is given to you when you write the KSP expression, right? So 1 mark. Okay, and then substitution according to the ice table. Okay. However, for this one, cannot use the assumption method since the given to you, the KSP value here is 10 power negative 4, which means very large number. So you have to solve by using quadratic, find out the value of Why? Okay, so only the positive value is accepted, remember? So this one not accepted, but you have to show. Okay, so to show these two, okay, these two y1 and y2 is another one more mark. Okay. Alright, so next C3, explain the difference in the molar stability calculated from 1 and 2. Right, so this is the sample answer. So we know that the molar stability of calcium sulfate in CaCl2 is lower in pure water. Okay, because of the presence of common ion Ca2+. Okay, so this is the first mark. Okay, first reason. Okay, concentration of Ca2+ increase. Okay, so because of we have Ca2+, more Ca2+, so concentration Ca2+ will increase. So or you can write shift the equilibrium to the left, or you can write reduce the stability of CaSO4 in CaCl2. 1 mark. Okay. Alright, so this just remark when system shift to the left side, left side, more solid CaSO4 will be formed, therefore stability will decrease. That's why solubility of CaSO4 in 0.2 molar CaCl2 is lower than in the pure water. Alright, so that's all from me. Hopefully you can do the best in your final exam. See you again in the next semester. Bye and Assalamualaikum.